Hello, everyone, and welcome back. I hope you had a great lunch break. Hope you guys are psyched for the last part of this conference. I'm here with Magda Stożek, which is a Scala developer. You're right now, if I'm not wrong, you're working at some cool Scala projects for the banking sector, kind of, right?
Yeah, as part of Software, which is a software house, I'm working with a Japanese client, working on payment, providing online payment options for people.
Cool. I've had a couple of toes dipped in Scala in my years, so I'm really looking forward to your talk about what's new regarding implicits in Scala 3. So when you're ready, please just take it away and teach us all about it.
Okay, thanks.
Oh, of course, attendees ask questions. Just put them in the chat or in the QA tab, and I will attend to them at the end of the session.
Okay, welcome everyone. I'm very happy to be able to talk to you today about implicits and Scala free. So right now I've been a Scala developer for around 5 years. And right now I can say that I enjoy writing Scala. I think it's a great language and I enjoy writing it every day. But I must say that the beginnings, they weren't so smooth. I found it hard and challenging to understand the various concepts of Scala. And one of the things that were the most confusing for me was implicits. There were times where I thought, I got this, I understand implicits. And then a couple of days later, I came across some other use of implicits, and then I was lost again. And I had to go back to my more experienced colleagues and tell them, okay, I know we have talked about implicits, but can you please explain it to me one more time in this context? What happens here? Fortunately, my colleagues were quite patient, and I got through this difficult phase, and I didn't give up Scala altogether. But I kept thinking, why does it have to be so difficult? So when I heard about Scala free, and when I heard that in Scala free, the concept of implicits is going to be completely redesigned, I got curious. I wanted to know more. I wanted to know if maybe in Scala free, the implicits are any simpler. Maybe it's a change for the best. So this is how this presentation came to be. Today, I would like to share with you what I have learned. So the plan for the next 40 minutes is, at first I will tell you a bit about what implicits are and why do we use it, why do we need it generally. What are some of the problems in Scala 2? So why are they so hard to understand sometimes? And then I will show you 7 use cases of code showing back-to-back Scala 2 and Scala 3. So how we used to solve some problems related to implicits and how we're going to solve them in Scala 3. And I will finish with a couple of words about migration. So let's start with talking about implicits. Where do we need it? Well, generally, the implicit keyword in Scala can be attached to various language constructs, and it helps us do a lot of different ways. What's common is that they define so-called contextual abstractions. So they are a way to abstract over context in your code. So let's say you have your code, it's running somewhere, but it's not running in the void, it's running in some context. And because of that context, you don't have to specify everything explicitly. Sometimes the compiler can infer some of the things from the context. So that's why it's called contextual abstractions. And it's a very important and a very powerful language feature in various functional languages, but in Scala also in general. And it can be used to do different things. Providing context is one of them. But you can also add functionality to existing types using implicits. You can define type classes, which are a very important feature in itself. You can use implicit conversions between the types. You can solve the dependency injection problem. You can express capabilities about your code, compute new types, and proof relationship between the types for your compiler. So that's already a lot. However, implicits are not always easy. So apart from being powerful, they have some problems in Scala too. One is that they can mean a lot of different things. The other is it can be attached to many different language constructs. So in Scala 2, you can have an implicit parameter, argument, value, object, def, and class. And it's not like they map one-to-one to the use cases from the previous slide. They actually can mean different things. So when you learn it, you have to learn the whole patterns. It's not enough to see the implicit keyword. You have to see more of the code to see whether if it's an implicit value, am I providing context or am I extending the type with functionality and so on. So these are the idioms or patterns that you have to learn. So this can be confusing and this can be not easy. Apart from that, it often happens in Scala 3, and if you ever did Scala in Scala 2, if you ever have written anything in Scala 2 with implicits, you might have encountered such situation. You have some code, it's running, it's fine. And then you copy some bit of the code to another class, another place, and then it doesn't compile anymore. Why? It's the same code. Often the answer is a missing implicit import. Because in this base class, somewhere in the long list of imports, you had hidden some import which imported an implicit value for you, which is just needed for this part of the code to compile. So when you find this import and you paste it to the new file, it feels like magic because finally the compiler is perfectly happy. So it's sometimes called implicit import incantations that you have to find and magically it works. And another thing, a bit of the opposite, are sneaky conversions. Because also sometimes in the long list of imports, you can have an implicit conversion imported, which means that maybe you don't even know about it, but the compiler treats some part of your or some type as another type. You don't even know about it, and it may lead to confusion and tricky bugs. So for all these reasons, this is implicits unfortunately are part of the reason why Scala sometimes has a bad reputation of being hard to understand, hard for newcomers, hard to read, and hard to fully grasp. So where does Scala 3 come here? Well, generally, Scala 3 is a major language rewrite. It actually took 8 years from the first commit of Scala 3 until the final release. And during those 8 years, what's awesome in my opinion is that the creators of the language have actually watched how we use the language, watched what works, what doesn't work in Scala 2. They have listened to our concerns, listened to our complaints, and they have decided that the release of Scala 3 is a release of a language which will be easier to use, so that the overall daily day-to-day developer experience will be just better, that the language will be simpler, that it will convey the intent more easily, that it will be clearer for the reader of the code what is defined and what happens here. So because Scala 3 addresses the pain points, it's probably not a surprise that implicits has been identified as one of the pain points, one of the tricky bits. And in Scala 3, the concept of implicits is completely redesigned to the point where the implicit keyword doesn't exist in the language anymore. You won't find it in Scala 3. So what do you get instead? Instead, you get a couple of new keywords which do one thing and do it well. So let's see those keywords in action. To show this, I have prepared 7 use cases where I will show Scala 2 and Scala 3 side by side. The first one is providing context. Then we will add functionality to an existing type. Then we will define type classes. And we'll talk about implicit conversions, implicit imports, unused names, and compiler errors. So these are the 7 use cases that I have chosen, which are, in my opinion, either the most widely used ways of why you would need contextual abstractions, or the most problematic, or just the most important, or the ones that I think is best illustrate the new concepts. So let's start with providing context. Generally, in functional languages, one of the main ideas of functional languages is that you get the parameters in the method signature, so that you know what the method can do. It cannot just take values for various different places if it's not defined there in the signature. That's the functional programming principle. However, this may have a side effect of the signatures being very long and the methods taking a lot of the arguments. So then it's quite easy to get confused, and your code gets to be very cluttered and so on. And for this reason, some of the things you may want to decide that it's just your context. Like for example, in the case of futures, where when you define a future in Scala, you have to provide execution context. So it's some kind of a thread pool on which the future it will run. And maybe you want to specify it once for the 20 or 40 futures that you have in your file, and you don't want to write it explicitly as a parameter to the method every time. So what you do, you say that this is a context. And for example, when you have the definition of the apply method for the future, this is the body. So what I have prepared in the curly braces here, the print line and the 42. But apart from that, you have an implicit parameter list where the compiler knows that you will provide to the compiler the execution context. And the way it is used in Scala 2, the way it's provided is with an implicit value of execution context. So if you have that, you can omit this execution context from the function call here. And this is Scala 2. And how does it look like in Scala 3? We define the futures the same way. And the way the apply method is defined is, apart from the body, you have this using keyword. So this is a using clause, and that's how you define what your method expects to be provided. And then where you provide it, you have the given keyword. So here you give the execution context global, and that's why the compiler needs to insert to your future definition. And this using and given keywords are one of the most important things in Scala 3 in terms of contextual abstraction, and you will use it quite often, I guess. Now, the second use case is adding functionality to an existing type. So to illustrate this, let's imagine a sample domain of a website with books, a website where you can share the books you have read, provide reviews, see what other users have read, and so on. And let's say this website also has reading challenges, so that you can specify at the beginning of the year that, for example, this year you want to read 12 books or 20 books and see if you're on track. But let's say that we need to now add a new functionality, because some of the users added books which are really short, like 5 pages long. And then their yearly challenge gets finished in January and nobody has so much fun anymore. So we want to add a new functionality to say that only some of the books qualify for the challenge, only books that are longer than 20 pages. So we would like to be able to invoke a method on the book type, whether it qualifies for the challenge or not. However, the problem is that the book class is defined somewhere in another package, in another library. It's a closed type, and we cannot simply add methods to it. So this is where the power of implicit comes into play. And in Scala 2, you can add such functionality using an implicit class. So you define an implicit class, you give it a name, even though the name won't be used. You say that it operates on your type book, and you define your method. It returns a boolean, and the body of the method is it returns true if the number of pages is more than 20. So this is how you do it in Scala 2. And how do you do it in Scala 3? In Scala 3, the same problem, you want to use it the same way, and the book type is still closed. But the way you define it is you use extension methods. So this is a good example of a new keyword, because extension is a new keyword, which does one thing and does it well. So you define an extension, you say that it operates on type book, so you are adding something to the book type. And here you have your method, the implementation of the method qualifies for challenge. What it means is that anytime you find the extension keyword in Scala free codebase, you instantly know what's being defined. You know that we are adding new functionality, new methods to an existing type. So it's much more clear. The intent is instantly known to the reader. And now let's talk about type classes. Type classes are a very important thing in functional languages in general, and also in Scala. So to illustrate when they might be helpful, let's go back to our sample domain. Let's say we have the books, but also some of the people said they don't read so much books, but they read a lot of the articles. They read a lot on the internet. So they would like to somehow take part in the reading challenge as well. But how do you score it? Is 12 articles the same as reading 12 books? Probably not. So let's say we got a feature request from our product owner that maybe right now the reading challenge will be about the number of pages that you read yearly. And then each book is worth the number of pages, but each article is worth one, because you cannot really decide. It's sometimes difficult to decide how many pages is a blog post on the internet or a newspaper magazine article. So we want to say that we have books and we have articles, and they are scored in a different way. Now, how do we solve it? If only book and article had a common parent, then we could define the scoring method in the parent and let the two children implement it with their own implementations. However, it turns out that book and article don't have a common parent. So what do? This is where type classes come in handy. They let you define this, what's called ad hoc polymorphism. So you take two unrelated types and you say that they share a common behavior. And to add this common behavior, you can use type classes. So what you do is you define in our case a scorable trait. So just a trait parameterized by the type, which has the method operating on this type. In our case, this is the score method because we want to add the score behavior on the type, and it returns an integer. And in Scala 2, we can implement such type classes like that. And actually, you can do it using implicit vals, objects, or defs. But for the sake of this example, let's use an implicit val. So we have the implementation of the scorable trait parameterized by our book type. We override the score method or the score behavior working on our type book, and the implementation is the number of pages. And similarly, we define the behavior for a scorable article. So here the score method takes the article and it returns always a 1, an integer of 1. And now that we have such behavior defined, we can use it here. So we have a case class current score, which holds the current score for this user for us. And we want to have an add item method, which can add articles and books. So what we do is we can parameterize by this syntax, t:\scorable. It's called context bounds in Scala, and it means that it works on type t, which has the scorable behavior. And the method returns new current score, and the implementation is it creates a new current score of the value so far, plus here, this implicitly of scorable is a syntax which says to the compiler, dear compiler, please just fetch me the appropriate type class for this type that I was called with. And then on this, we can call the score item, and it will have the correct definition according to whether it was called for a book or for an article. And this is how you use this type class. And right now we can have the behavior that we wanted, so that we construct the current score of 0. We add an instance of type book. And right now the score is being calculated to 600. And then when we add an item of type article, the current score is 1 is added to it, so it's 601 now. So we have achieved what we wanted. This is the power of implicits. But if you don't like this implicitly keyword, and bear in mind it's still Scala 2, you can use it also in a different way. So everything else is similar, but here this add item method is parameterized just by the t. But here, apart from the item, you also have another implicit parameter list where you have the scoring instance of the type class. And then because you have a named instance here, you can just use it by a name here. The behavior is the same, so it's a matter of preference of which one you want to use. So let's move to Scala 3. How does Scala 3 define type classes? Our desired code looks the same, and the trait we define the same way. But the implementation is by those given instances, which the keyword we already know. So we say that we have a given scorable of type book, and we override the score method working on the type book. The implementation is number of pages. And in the same way, we define a type class, implement a type class for a scorable of article with the right implementation. And the way we use it is here also we have the two ways. So with context bounds, we just parameterize it by the type t, implementing the scorable behavior. And here, instead of the implicitly keyword, we have a summon keyword. So even for such a small thing, the implicitly keyword is gone and it's replaced by a new special keyword, summon. But the behavior of this is completely the same. So it just fetches the type class of the appropriate type. And if you don't like the summon keyword, you can use the other idiom, let's say, or the other way of writing it. You also have another parameter list, but with the using keyword, because you don't have implicit, you have using now. And right now you have a named instance and you can just directly call it. So this is how you define type classes in Scala. A very important thing and also needed when using some libraries. Let's now move to conversions. Let's say that somewhere in our domain, apart from books, we also have items, a notion of item. And this is a simple implementation. But what's important is that we also have this beautiful print item method, a very sophisticated, very special and unique print item method. And if only we could call the print item method on instances of the type book, but it only operates on item. And again, it's somewhere closed, we cannot change it. What we can do, having powerful implicits, is we can define an implicit def method, which takes the book type as a parameter and returns the item type. And its implementation is just calling the case class constructor with the book title. And if we have such an implicit definition in scope, then the compiler will accept the code like this. It will know that where it expects items, it can also pass books, because we have given to the compiler a recipe of how to convert it. However, this is implicit def, and implicit def is something that we can also use for other things in Scala 2, and that's one of the problems, the confusions. With Scala 3, to achieve the same way, we use a special conversion class. It's a Scala.conversion class, which is parameterized by the book and item. So in this case, but generally the source type and the target type. And it has an apply method that you need to define or implement, taking the source type as the parameter, returning the target type. And here we have the implementation similar to it. So what's important here is that you get a special class. And when you look at new code and you see this conversion class parameterized by two types and with an apply method, then you instantly know what's going on. It's an implicit conversion. You tell the compiler to treat some type as some other type. So what Scala 3 did is it made implicit conversions much more explicit. And a bit related to that is importing implicits and generate the imports. So I have mentioned this problem with long list of imports where something can be hidden, an implicit import can be hidden and you don't even know it. And in Scala 2, it's perfectly fine for the code to compile it like this. So you have some future, you construct the future, and you have an import with an execution context imported from that package. This is fine in Scala 2, but this will actually not compile in Scala 3. The same code. Because what this syntax in Scala 3 means is please import everything apart from given instances. So actually the given instances won't end up in the scope of my code here. And if you do want to import the given instances, you need to use this syntax. So this package name.given. And only then will our code compile. And the good thing about it is that now when you have a long list of imports and you wonder which one you need to copy or to use in your new code, you instantly see which of the imports bring the given instances. So you can select just from them which is the one you need. And if you really do want to import everything from a package, that's not a problem as well. You can use this curly braces with given, comma, asterisk, and then it will truly import everything from that package. Of course, if you only want to import one specific given, then you can just import it using its name. So that's fine. And another thing that was sometimes a bit annoying in Scala 2 was mandatory names for your implicit instances, implicit values. So let's say, still in our domain of books website, that we want to order the books. We want to sort them because maybe we want to display them. So here we have a sequence of books and we don't want to reinvent the wheel. So we are using the built-in capabilities of the language. So for the sequence type, we can use the ccop straight, which has a sorted method implemented. It takes a b parameter, type parameter, and here it has an implicit parameter list in Scala 2, because you have to somehow provide what is your recipe for the ordering of books. The compiler doesn't know it out of the box. So maybe you want to say that the longest book goes first, or maybe you just want to sort it alphabetically, and so on. You have to provide it. But this is another example of providing context. So I don't want to specify my sorting mechanism everywhere where I sort the books, because I really have maybe just one sorting mechanism in all of my system, and I don't want to repeat it again and again so that it doesn't clutter my code. So what I need to provide in Scala 2 is I provide an implicit value, an instance of type ordering parameterized by the book, and the implementation is that for two books, it compares their titles alphabetically. And here in Scala 2, I always have to provide the name, this by title name, even though it's not used here in the sorted invocation. But I still have to provide it. So now it's not like it's a big problem. It won't prevent you from understanding the code or something like this, but it's just, naming things is hard in writing programs, right? So that's just another decision that you have to make in your day. A little annoying thing, because do you use a single letter name or do you provide a meaningful name? A small decision to do. And this is a small annoyance which is also addressed by Scala 3. So I think that's a nice thing. And you already know that you provide this context by the given keyword. So the equivalent code would be written like this. And if you want, you can provide the name here for the ordering of book. But if you don't want to, you can just omit it like this. And this way, The compiler has everything it needs because it has the type, it has the implementation, and it doesn't need to use it. So it's your choice. Do you want to provide a meaningful name? That's fine. But if you can't be bothered to think of a name, or you think it would clutter your code, it's totally fine to omit the name. It's called anonymous givens then. And the last nice thing in Scala 3 are different compiler errors. Because generally in Scala 2, if you work with implicits and you don't get your implicits right, then the compiler errors are a bit helpful, but not extremely helpful. So for example, here, it says that it could not find implicit value for evidence parameter of this type. So I know what type was missing, but I don't know where. And sometimes it's obvious which methods needs an implicit. But sometimes it's not, because maybe you have a long chain of calls and your IDE doesn't really show you which one of them is missing, and so on. And in Scala 3, this is fixed. So in Scala 3, when you are missing an implicit, you not only see what type of implicit is missing, but here it tells you for parameter scoring, so that's the name of the parameter, of method add item, so that's the method name, in class current score. So you have the class name, the method name, and the parameter. And it's much easier to find the right implicit then. What's more, sometimes the compiler will try to be extra helpful, because sometimes it will even suggest the import that you might be missing. Of course, it won't always be right, but it often is right for at least the most used, the simplest cases. And for me, when playing around with the code, forgetting implicits and then checking what the suggestions of the compiler was, it felt almost sometimes too easy. Okay, I am missing this, I am adding this, go on, I am not losing my flow. I just write my code faster and don't have to stop think about the right imports for such cases. So these were the 7 use cases. And if you'd like to start migration to Scala 3 in terms of contextual abstractions, how do you go about that? Well, I said that the implicit keyword is gone from Scala 3, but does it mean that you have to do a major rewrite all at once? No. There's some grace period. For now, it's at least 3.0 and 3.1 version of Scala, where the implicits and the new constructs can live together. So for example, maybe you are using an old library using imports, and your code is already migrated to givens and using. They will be able to work together. And also the other way around, if you are using a library which is newer and your code is older, that's still fine. They can live interchangeably and they will work just fine. And only then in the future, in some version of Scala 3, you will start to get compiler warnings about implicits. And then only sometime after, you will get compiler errors. And then will be the time to get rid of implicits altogether. So to sum up, in Scala 3, contextual abstractions is you can define it in a clearer way in your code, because the new keywords allow you to specify the intention. So you say what you want to do, you want to write in your code, and not how to do it, not the mechanism, which was the case in implicits. And actually, this is along the functional programming principles as well, where you specify what you want to do and not how you want to do it. So with the new keywords being mainly given and using, the extension methods, and the conversion class, and with some help of the clearer imports and more helpful compiler messages, in my opinion, writing contextual abstractions in Scala 3 really will be a better developer experience. It will be easier to get it right when you code it. It will be easier to read when you are new to the code, and even if you are new to the language. If you'd like to know more about contextual abstractions, There's also a whole new feature called context functions, which I haven't covered here because it doesn't have a direct counterpart in Scala 2. But it's a cool feature, so if you're interested in contextual abstractions, go check it out. If you'd like to know more about the features that I have covered, the Scala free documentation is nicely written, so you can get to know more with more examples and so on. And when you are ready to migrate, do take a look at Scala free migration guide page. There's a lot of resources on how to start and what steps to take when you migrate and so on. And if you'd like to play with the code that was included in this presentation, then you can clone those two GitHub repositories, which I have prepared. They contain the codes from the presentation, so you can run those two together in Scala 2 and in Scala 3 and see the differences, play around with it. Thank you for your time. I hope you have some questions. And if you have any feedback or comments about the presentation, you can scan the QR code below or go to the link below. Thanks.
Thank you, Magda. Thank you very much. Great presentation.
Thank you.
I don't think we have any questions. Hopefully you guys can type them in as me and Magda are rounding off here. But to me, it looks like Scala 3 has taken away a lot of the pain points with dealing with Scala. And I recognize the little use case you had in the beginning where I just copied this code from this other file. Why is it not working? Why?
Yeah.
It's always the missing explicit.
It's a relief now.
Yeah. Let's see if we get any reactions. We got a lot of thumbs up and a lot of great reactions, but no questions. So
okay, if someone comes up to anyone's mind, I'll be around during the conference or in Twitter.
Great, and we can always have the chat for this track is always open, so you can always come back there and ask Magda questions. You can just @ her and she'll get a notification. So no new questions. Then I would like to once again thank you very much for your presentation. Lovely to have you here.
Thanks for having me.
And for you attendees, we will have a short break, and I think we'll be back in about 13 minutes. Yeah, past. So have a nice break, take a cup of coffee and stretch your legs, and I'll see you guys in a couple of minutes again. Thank you again, Magda, and thank you guys for listening. Bye. Great.